Welcome to part 2 of the video on dot products. It is highly recommended that you've already seen the first part of the dot product videos before watching this. Let's look at algebraic properties of dot products. Let's assume we have 4 vectors a, b, c, d, and that they all have x, y, and z components. The first property states that the order for dot products don't make a difference, so a dot b is equal to b dot a. The second one says if we were to take the dot products of a vector by itself, we get its magnitude squared. The third property states that if we have vector a dot vector b plus vector c, we can use the distributive property to get a dot b plus a dot c. Finally, if we have vectors a plus b dot vectors c plus d, then it's kind of like binomial expansion, so we end up getting vectors a dot c plus vectors a dot d plus vectors b dot c plus vectors b dot d. All of these properties can be proven by using their components and performing whatever operations to the left-hand side and the right-hand side and comparing the two sides. Let's look at an example here. We got vector a dot vector a, so we're going to use their components, and that's ax times ax plus ay times ay plus az times az, and that ends up being ax squared plus ay squared plus az squared. Ax squared plus ay squared plus az squared rooted and squared is same as the line above, and the root of x component squared plus y component squared plus z component squared is same as the magnitude of vector a, and that's just squared, and that proves that the left hand side is equal to the right hand side. As stated in the previous video, for perpendicular vectors, their angle between them is 90 degrees, and using the other properties of dot vectors, meaning a dot b is equal to magnitude of a magnitude of b times cosine of theta. When theta is 90, cosine of 90 is equal to 0, and therefore when two vectors are perpendicular, their dot product is equal to 0. For parallel vectors, the angle between two vectors can either be 0 or it can be 180 degrees. When the angle is 0, the dot product is going to equal to the magnitude of vector a times magnitude of vector b times cosine of 0. Cosine of 0 is equal to 1, and therefore that means that the magnitude of a times magnitude of b equals to the dot product of vectors a and b. When the angle is 180 degrees, the dot product is going to equal to vector a magnitude of b times cosine of 180, which is -1. And therefore, that means that the magnitude of a times magnitude of b is equal to negative the dot product of a and b. Therefore, for vectors that are parallel, we can say that the magnitude of vector a times the magnitude of vector b is equal to plus or minus the dot products of vectors a and b. Plus or minus can be written as absolute value, so the absolute value of dot products of a and b is equal to plus or minus the dot products of vectors a and b, and therefore we can summarize everything and say that the magnitude of vector a times the magnitude of vector b is equal to the magnitude of the dot products of vectors a and b. Whenever we take the dot products of two vectors where the cosine of the angle between them is less than 0 or negative, that means their dot product is also negative, and when the angle is positive, their dot product is also positive. Note that if we're taking the angle between two vectors, we always have to take the angle between 0 and 180, and we're never looking at the angle which is larger than that. And that's something that we need to keep in mind whenever we're taking dot products. The summary of the lesson is summarized here, so if you want to slow down the video and write them down, please feel free to do so. And now we're going to look at a few examples. For the first example, we want to show that a triangle with the vertices given, a, b, and c, is a right triangle. With the new skill that we have learned, we know that the dot product of two vectors that are right angled to each other is equal to 0. So we're going to find all the vectors corresponding to all the vertices here. So Vector AB, we're going to take all the x, y, and z components of B and subtract them by the components of A. And we're going to do the same thing to find all vectors AB, BC, and AC for our triangle. Let's draw out the triangle with vertices A, B, and C. To test for 90 degrees, we're going to take dot products. The best things to do is vectors AB, AC, BA, BC, and CB, CA. In this case, I've taken AB, BC, which is incorrect. It doesn't give me the proper angle, but if it was 0, it still does tell me that angle B is 0. Next, we'll look at the dot product between vectors AB and AC, which should give us information about angle A. And we'll multiply their x components, y components, and z components and add them together. In this case, we get 0. And this means that since the dot product of vectors AB and AC is equal to 0, that these two vectors are perpendicular to each other, and this means that we got a right triangle. For the next example, we want to expand and simplify the following, and we're going to be dealing with some unit vectors now. Okay, we're going to use a distributive property. Here we got 2 times the unit vector I dot 5 times unit vector j minus 3j dot 5j. Here we get 10 multiplied by the dot products of I and j minus 15 times the dot products of j and j. Note that when we plot out I and j, their unit vectors in x and y direction, they are perpendicular to each other, meaning that their dot product is 0, so we get 10 times 0. And j times j, using our property, j dot j will be the magnitude of j squared. The magnitude of j is 1, it's a unit vector squared, that gives us 1. So we get 10 times 0 minus 15 times 1, which is negative 15. Our next question is going to be a little bit more challenging. So if the angle between unit vectors A and B is 60 degrees, we want to determine 2a plus b dot a minus 3b. Note that whenever we have the hat, that does mean it's a unit vector and that its magnitude or size is equal to 1. We're going to start applying the binomial expansion. We got 2a dot a minus 2a dot negative 3b. And we're going to add that to b dot a plus b dot negative 3b. And if we put that together, we get 2 times a squared plus 6a dot b plus a dot b minus 3 magnitude of b squared. Since the magnitudes of a is 1, so we get 2 times 1 squared plus combining the 2 there, we get 7a dot b minus 3 1 times 1 squared. We get 2 times 1 is 2 plus 7 times magnitude of a times magnitude of b times cosine of 60 minus 3. Since the cosine of 60 is 1 over 2, we get 2 plus 7 times 1 for the magnitude of unit vectors times 1 over 2 minus 3. We have fractions, so let's get a common denominator of 2. We get 4 over 2 plus 7 over 2 minus 6 over 2, and our final answer ends up being 5 over 2. I have prepared 3 questions for you folks to try out. I will try to post up the full solution to these in a separate video as soon as I can, and I hope that this video helped you understand dot products a little bit better. Thank you for watching.